All right, so we might get started. So welcome everybody. It's lovely to see you all on the call. Thank you very much for joining us today at our Lunch and Learn. I'd like to begin by acknowledging the traditional custodians of the lands that we are meeting here today. I pay my respects to elders past, present and emerging, and celebrate the diversity of Aboriginal people and their ongoing cultures and connections to the lands and waters of Australia. I also acknowledge and pay my respects to our Aboriginal and Torres Strait Islander people joining us today. So welcome everybody. My name is Kirsty Miller and I am DiUS's Head of Strategy and Growth, and I'll be joined today by my colleague Shahin Naman, one of our machine learning specialists here at DiUS. And we're going to be talking today about what everyone seems to be talking about right now, machine learning, artificial intelligence, and generative AI. So what specifically, I'll just share the agenda. So we're going to be talking about machine learning trends through the lens of our DiUS machine learning research, augmented with observations about what we're seeing on the ground, with the aim of giving you some insights with what's happening in this new and exciting area, as well as within more traditional areas, but perhaps less well-known areas of machine learning. We'll be looking at adoption, business drivers and tools technologies, as well as providing some case study examples of real-life applications we've worked on with our clients to deliver some impressive results, both in predictive AI and generative AI. So without further ado, for those of you who already know us at DiUS, hello again. But for those of you who are new, I'll just do a 30-second introduction about who we are and what we do. DiUS is a technology consulting company that builds custom software and hardware solutions for clients. We have a unique and broad skill set that spans data, devices, and digital, making us the perfect choice for clients who are looking to build things like data-driven digital platforms, machine learning-powered products, or edge AI solutions designed to improve customer experiences or solve problems that haven't been solved before. So our team is based across Australia and New Zealand. And in fact, we just celebrated our 19th birthday this month. So happy birthday to us. And then just a little bit of housekeeping. If you have any questions today, we're more than happy to answer them. We encourage you to ask them via Slido. Erin has just popped the details in the chat. You can either scan the QR code on the screen now, or you can go to slido.com and enter the code that you can see there. There'll be plenty of time for questions at the end. So, the rise of generative AI over the last 6 months has dramatically changed the artificial intelligence landscape. We've all seen it, we've all heard about it, we've all read about it. The release of OpenAI's ChatGPT late last year made AI accessible to just about everyone, and I guess has kind of captured the imagination of the general public and businesses alike. You can see just included some random headlines here, just a tiny amount of what we've been seeing everyone. And I guess, the point is it's making a lot of noise, both for good reasons, and then also there's a lot of risks and dangers, floated out there. So I guess really, like any technology, there are risks and benefits. And if you understand them both, you can understand what you can use Gen AI for, how to use it safely, securely, and responsibly. So people from all walks of life are now using AI for personal productivity, and businesses are also using it to power new features and products. And I'll bet almost everybody here on the call has tried it in one form or the other. I know I have. And then also OpenAI, Facebook, major cloud vendors, so AWS, Google, Microsoft, and many others have all been jockeying and releasing and announcing their models and services for generative AI. So there's a lot happening in this space, and it's led to the rise of terms such as generative AI, foundation models, LLMs or large language models, prompt engineering. These may or may not be new to you, but we're going to be demystifying these a little later in our talk. So ultimately, generative AI has put AI at the front of of everyone's minds, it's actually made getting started with artificial intelligence much easier. And we at DiUS are having more conversations about AI than we ever have before, and we've been in this space for quite a long time. And I guess the general sense that we're getting from organizations is people are feeling this real sense like they have to act or risk being left behind. So with that aim in mind, today we're going to share our Machine Learning Pulse report, how the rise of generative AI may have impacted our findings, and then shed some light into what generative AI is, where it can be applied, and how it's being adopted. So for those of you who are new to DiUS, we have a publication called the DiUS National Pulse Report, and it looks at machine learning adoption in Australia, and for this year, New Zealand. We do a national survey. We ask a variety of questions about machine learning adoption, business drivers, what challenges are people facing them, what's stopping them. And for the 2023 report, we had close to 400 respondents. And we've done the report for 2 years now. And I guess we started collecting this data as a way to provide some local data on what's happening with machine learning. Like, there is lots of data around. There's heaps of reports and surveys, but there's not a lot just specifically focused on the Australian and New Zealand market, and not a lot diving into the areas that we specifically wanted to focus on. So the results we are sharing today come from the latest version of the report, the 2022-23 survey report, but the data was collected before OpenAI released ChatGPT late last year. So the results don't include its impact. So what we've done today is to kind of draw together some key results that remain meaningful to this talk, and then add our interpretation of the impact of generative AI as, interpreted from our investigation, what we've been seeing on the ground, the many conversations we've had with our clients and prospects over the last, 4 or 5 months. And before I dive in, I guess one really important thing to emphasize is that generative AI is hogging the spotlight right now. It's all about Gen AI, and it is extremely impactful. But it's only one application of artificial intelligence. There are many others, that have been advancing for years, maybe invisibly to the majority of the market. And I guess these still remain extremely impactful and influential to businesses. So it's not everything is about generative AI, I guess is one point to make. So without further ado, we're going to dive straight into adoption. So adoption, everybody always wants to know how much of the market is actually using and applying machine learning. So we tend to look at machine learning adoption as a journey. So when we looked at the data from the close to 400 responses of the surveys, we found that 15% have not started, 30% are considering. So they're in that stage where they may have found an appropriate opportunity or problem to solve with machine learning, but they haven't started. They're thinking about it, but they haven't started. 32% are experimenting. So this is where machine learning is being used in a proof of concept or a pilot investigation. And then 23% are the most mature. They're applying. And this is where they have machine learning models in production or being ready for production. So when we look at the machine learning journey, we can see that within our sample, we had 85% of organizations that have started their machine learning journey. And 55% can be considered adopters of machine learning. So this is the group that's actually hands-on with the technology. So that's the people that are experimenting and applying. And then when we asked respondents, how they saw machine learning going forward, again, it was 85% of respondents that saw machine learning as a critical part of future success, or one of several important contributing technologies. So you might be asking yourself, is this a good result? Is it a bad result? What does this actually mean? I think I think that you can't describe it in absolute terms. You can't say it's a good result or it's a bad result, but there are a couple of observations to help us, I guess, really understand the broader context. So firstly, it's really encouraging that there's this tremendous amount of interest in machine learning. However, perhaps it's a little discouraging that despite this huge amount of interest, so 85% of the respondents say that they're interested in machine learning and they've started machine learning, there's still only 23% with machine learning models in production. And I guess another thing to note is Australia is behind many countries that we lag behind in terms of the amount of mature organizations deploying machine learning that actually have models in production. So at 23%, we're definitely behind China and India, a lot of countries in Europe, and also Singapore and Korea. Another thing you might be asking yourself, okay, so 85% started a machine learning journey. That's kind of a lot. What do we think generative AI has done to these results? Well, from what we've been seeing on the ground, there would be a definite increase in the experimenting stage. We feel there would have been a larger number that had moved from the not starting into the considering and probably straight through to the experimenting stages. We don't think we would have seen much movement in the applying stages yet. I think, as we go further on this talk, an important point or takeaway perhaps is that while generative AI has lowered a lot of barriers and is really moving fast and creating a lot of activity, there's still a lot to understand about how it works and what are the best use cases. So for the first time, we collected data for our survey report across Australia and New Zealand. You can see the results here, and really there doesn't appear to be a lot of difference between the two countries, and indeed a lot of difference to the results of the overall sample. You can see some minor differences. New Zealand has less percentage of respondents in the mature stage, and they've got slightly more respondents in the not started stage, but it's pretty similar. But leaving aside those similarities or differences, I think there are a few observations that we wanted to make specifically about the New Zealand market. And I think this really comes from the addition of some ground truthing, if you will, from our most recent visit there in March. There is strong interest in machine learning, particularly in generative AI, and also, which is particularly exciting to us, in the combination of machine learning and IoT to deliver edge AI solutions. At DiUS, we are very interested in that particular combination. And another key call out for the New Zealand market is the New Zealand market is also experiencing a lack of skilled machine learning resources, a blocker that may be affecting this region more than others. And then lastly, and probably not surprising to anyone, the most interest in machine learning in New Zealand is coming from the agribusiness industry. So next, we wanted to share the results around whether or not machine learning adoption is trending upwards. This is something that everyone is always interested in. They want to know how much it is, what other organizations are doing, and whether or not it's increasing and decreasing. So here you can see the results from the two samples, from the two reports that we've done. And there's really not much difference. We were really, I guess, surprised at this finding that there wasn't much of an increase from year to year. We did do a bit of research on this, and we weren't alone in getting this result. There were other surveys done last year, not necessarily in Australia, that did show the same result, that there seemed to be a bit of this pause, like people were kind of taking a breath. We did expect an increase. We did expect more movement. And the reason why was all the survey data from 2021 suggested that things would move forward. There were three kind of key call-outs from what we found that suggested that this would be the case. There was really strong current interest. There was really strong future interest. And then also too, I guess maybe very significantly, of the people that had not started, over half of them have said, no, we're going to start within 1 to 2 years. So we felt really quite confident that machine learning adoption, would accelerate. And also too, there would be more movement within the stages. And I guess really, it's only been with this movement towards generative AI, which we spoke about when we were talking about adoption. Generative AI is what's delivering that increase that was expected. So to recap what I said earlier, we feel like there would have been a definite increase in the experimenting stage. This would have resulted both in an increase in like the overall percentage of adopters and also more organizations overall starting their machine learning journey. So what was stopping, what was holding organizations back? What was causing this bit of like, I guess, pause or people holding their breath? Well, you probably guess, a number of the factors. One of them was COVID. I think, over 50% of people said that COVID halted their plans to implement machine learning. And I think we could also probably point to the recent economic downturn prolonging that trend. Another factor was skill shortage. This is always a factor that's holding organizations back from adopting machine learning. Over half of the sample said they had none or limited internal machine learning capability. And I don't think that this finding is a surprise to anyone here. Machine learning skills have been at the top of the list for in-demand skills for quite a while now. And then lastly, beyond these two key points, we asked organizations about a variety of challenges that they were having, to really unpack what stops people from adopting machine learning. And we're going to talk about that a bit more next. And a good proportion of respondents, no matter where they were on their machine learning journey, said that the challenges that they were facing impacted their adoption. So that's a big thing into what was previously holding organizations back. So when we look at the challenges to adopting machine learning, we tend to look at them in relation to where you are on your machine learning journey. It's been our experience that it really does depend at what stage you are at in terms of what challenges that you're facing. What are the biggest barriers? One caveat to that is that data is always, no matter what stage you're at, if you've started your machine learning journey, data is always a big factor and always in the top 3 challenges. So if we look here at the experimenting stage, we can see that designing the proof of concept or pilot to deliver measurable outcomes, lack of specialist skills and data are the top 3 challenges or blockers that organizations face. When we move through to the applying stage, you can see that once you get more mature with machine learning, data's obviously still an issue, but issues with integration, model accuracy, and performance raise their head as models are put into production, either delaying or preventing machine learning project success. We don't expect these to go away for predictive AI. These are challenges that we continue to help our clients with to this day. However, interestingly, and one of the reasons why we feel like there would have been this, increase in adoption of machine learning fueled by generative AI, is that with generative AI, some of these challenges may become less significant. So for example, it's much easier to get started with Gen AI without specialist skills. There is less data required to get started, and there are less infrastructure needs if results can be obtained by using Gen AI services via APIs. Another call out too is the fact that generative AI can actually help to provide additional or better or the right data for machine learning to help model training through the generation of synthetic data. So there's quite a lot going on here, which leads us to believe that these challenges are going to be reduced if you're working with generative AI. Now to business drivers or business priorities. So, we kind of asked the question, are machine learning business priorities shifting? So in 2021, we found the top ML use cases were internally focused. The top use cases were operational efficiency and business decision making. So a lot was happening behind the scenes, but the survey data did predict a change. So we predicted that there was going to be this shift to internal and external use cases. We were going to see machine learning, I guess, making more of an impact in customer-facing situations, or perhaps opening up new revenue streams, more machine learning powered products, if you will. And indeed, that is what our survey showed. So if you look at the use cases for the most recent data, customer experience and support actually rocketed to the top, closely followed by operational efficiency. And then the rest of the use cases followed behind, which you can take a look at. But we expect this internal and external, I guess, dual focus to be accelerated by generative AI. And while generative AI can be used across all of these use cases, currently we're seeing it most in the first three areas: customer experience and support, operational efficiency, and also sales and marketing. And Shahin is going to talk a little bit more about this. So before I hand over to Shahin to dive deeper into generative AI and some case studies, so do we expect generative AI to shift machine learning business drivers? We absolutely do. We sure do. The barriers to entry have been lowered. And I guess, using it is not without risk, and it's not going to solve everything, but we're definitely going to see more of it. So I'm now going to hand over to Shahin, and I'm going to let Shahin to go ahead and share his screen so he can share his slides. Thank you, Shahin. Over to you.
Thanks, Kirsty, and thank you everyone for joining us. From this point on, we will go through an overview of generative AI, and we will try to demystify some of the terms that you hear these days when people talk about generative AI. Also, we will look at a few use cases and case studies. When it comes to machine learning, we can categorize the applications into predictive AI and generative AI, and similarly, the models can be categorized in these two categories. Predictive AI are the problems where you have a single correct answer to your problem. The purpose of the model that you implement is to solve one specific problem, so it's very narrow. And the way we go about these problems is to train a model using a training data set, which includes a set of input and desired outputs, where we use to train a model. And after that, your model learns to give you the predictions for an input that it hasn't seen before. So an example of this can be to pass an image of a cat to a model and ask the model what is inside that image. And the model will come back and say, this is an image of a cat. So there's a single correct answer to this problem, as I just mentioned. Whereas in generative AI, there is usually more than one correct answer to the problem. And the purpose of such models are usually to generate data. These models are pre-trained on a lot of generic unlabeled data. And because text and image collections are available these days, you can find Wikipedia and the internet has text as an example, and images are everywhere, and also audio. You can see that most of the commonly talked about models in generative AI are either image or text-based or audio. The underlying models behind these applications are called foundation models that we will talk about. And as I mentioned, usually the outcome is to generate data. An example of a generative AI application is if you ask a model to try to generate images of a cat that is sitting and it is black and white. And the model might come up with many, many different variations, and all of those are correct answers to the problem. So foundational models are actually the models that are making generative AI possible these days. These models are trained on very large amount of unlabeled data. So this data is not specific to a problem. It is usually very generic. It might be the whole internet, it might be Wikipedia, or it might be other sources of the data. And when you train such models, or actually pre-train such models, these models can be adapted to solve many, many different problems at the same time. We've seen in practice that these models can solve predictive and generative problems. So you can ask them to generate data, or you can ask them to do specific things for you. And as I mentioned, common foundation models these days are mostly text and image. And these can be tweaked with a very small amount of data to do specific tasks, and that's the adaptation of these models. The way we interact with such models is through prompts, which are basically usually text, and in that text you instruct the model to do a specific task for you, and you might send some data to that. As you can see on the screen, a foundation model can be trained on different types of data, and you might adapt it to do specific tasks such as sentiment analysis or information extraction and other specific applications as well. So foundation models that we hear these days are either for text and natural language processing, or for image. When we talk about natural language processing, these models are usually called large language models. And the same model can solve many natural language processing tasks. So it can be used for text classification, attribute extraction from a text. It can be used for sentiment analysis, summarization of a text. A very good application of these models these days are conversational AI and chatbots. They can also be used to produce content, which is a generative AI problem. These models have a very large size, so hosting of these models might be a bit of a challenge if you are having your own large language models. And the building block behind large language models are transformers. Transformers have been around since 2017, so it's not actually very new, but we are hearing large language models a lot more these days after ChatGPT. So examples of models, large language models, are GPT models that are provided by OpenAI. Palm is another example that is provided by Google. Llama by Facebook. And we have Bloom, which is an open source model, and so on and so forth. So as I mentioned, these models can be tweaked to do specific tasks. As an example, conversational AI and chatbots. And we have different models such as ChatGPT and Bard by Google that are specifically designed to do to be applied to conversational AI problems. When we are interacting with these models, we write them through prompts. So prompt is usually a text that you send to the model, and that's how you instruct the model to do a specific task for you. There are a few terms that you might hear when people talk about large language models. One of them is tokens. So token is a single unit of text. And the definition of token is model specific. So when you are interacting with a model, you might look and see how tokens are defined. And the reason this is important is that if you are calling an API, you are usually charged by the number of tokens sent and generated. Examples of tokens for different models can be the number of characters, it might be words, it might be subwords, and so on and so forth. Another term that you might hear when people talk about large language models is temperature. Temperature is actually a parameter that controls the variation in the output text. So if the temperature value is set to 0, That means that the model will always give you the same response when you send the same prompt to those models. And you can increase these models to add more variation to the output that you are getting, and more creativity is observed when you increase the value of temperature. And this is a parameter that you send to the model along with the prompt usually. Another types of foundational models these days are visual models. There are two different categories of foundation models. So these are the models that are foundational models for computer vision tasks. So one category is designed specifically to generate or modify images. Examples of these that you might have heard of are Stable Diffusion. Midjourney has lots and lots of different models that are specifically designed for artistic image generation. We have Imagen by Google, we have DALL-E by OpenAI, and so on and so forth. So the way you interact with these models is through text prompts, usually. So you send a text to these models, you define the scene, and the model might generate a photo or an image for you. So an example you see here is an astronaut riding a horse in a photorealistic style, and that's the image that is generated. There are other groups of visual foundation models, and these models are the models that try to solve different computer vision tasks at the same time. So it might solve problems such as object detection, instance segmentation, and semantic segmentation, where it goes and tells you what each pixel corresponds to, and so on and so forth. And it's a single model that you can use for all these different computer vision tasks. So examples of these are SAM and Dino version 2 by Facebook. Of course, there are other models like Swing Transformers by Microsoft, and so on and so forth that do these. The building block of computer vision foundational models are visual transformers, which look very similar to transformers, and they are just tweaked in such a way that they can go and process small batches of image. And the way we interact with these models are either through text prompts, as you saw in the examples at the top, or it might be visual prompts, which are either an image that you send to these models, or it might be a set of pixels that you select from an image, and that's how you define what you want the model to do for you. So an example of that is if you select a few of the pixels of the objects in the image that you are interested in, the model can go and do semantic segmentation, or better say instance segmentation for you, and choose all the pixels with which are associated with that class for you. So how do people work and interact with foundational models these days? We see that this is happening in two different ways. One of them is through prompt engineering, where you, through a process of trial and error, you try to modify and change your prompt in such a way that the model will give you the results that you expect. It's usually a trial and error process. It's not really hard to do these, but there are many, many different techniques that people use for prompt engineering. And it can be the subject of another talk that we can talk for an hour about how these prompt engineering is done in practice. What happens is the people change actually the input or the prompt that they are sending to the model, and it doesn't change the underlying structure and architecture of the model behind the hood. So the same model will give you different responses by changing the prompt that you are sending to those models. Whereas a different way to work with foundational models is to fine-tune them, and this is to try to change the model by passing sometimes a very small amount of additional data to those models. And this way you can tune the model to do specific tasks for you. So an example of that is Bloomberg GPT, which is a foundational large language model that is trained on financial data by the Bloomberg company. And the model they've used is inspired by Bloom. Of course, there is some name similarities there, and that might be the reason that they've chosen Bloom. But Bloom is an open source model that they could use and change according to their requirements. They've used a combination of general purpose and domain-specific data sets in order to train their financial model. And an example of what this model does better than the other models is what you see on the screen. So if you ask for the name of the CEO of a specific company, Bloomberg GPT has given the right answer. What GPT has provided is actually the name of the CEO of the company until 2021. It has changed recently, and that might be another reason that you want to fine-tune these models to work with more recent data. And T5 model has totally wrong answers to this problem. So this is an example of fine-tuning a model. We usually recommend fine-tuning when you have a specific problem in hand, when prompt engineering doesn't give you the right performance. You might want to do this because the data that you have is specific to your problem. So that might be another reason that you might want to fine-tune your models. So far, we gave you an overview of what generative AI is, what are the terms that you hear these days. But let's just step back and see how we used to do predictive AI or traditional ML before, and what were the options that we had. So when it comes to traditional ML or predictive AI, there were machine learning as a services that were usually provided by cloud providers. And these were a set of APIs that would do generic tasks for you. It might be to read text from an image, or it might be to translate text from one language to another one, as an example. So this is one way of using machine learning models. We've seen that this is used in practice a lot. And since you just call an API and you just pass the data, the complexity is really low. You don't really need to know how that model is working, how the machine learning behind the hood works. But usually the performance you get is not really high, because these services provide generic solutions to problems. And if your problem is specific, these are probably not the right options for you. The second option is AutoML. So AutoML requires you to have your own data. You just pass your training data set of input and output to these services, and they come up with a model for you. So the amount of complexity that you are dealing with increases, because you need to have a data set that is specific to your own problem. But again, you don't need machine learning skill sets. But the performance that you get is actually a little bit lower than custom models. And this is what we've seen in practice, that many organizations start with AutoML, and they might come and talk to us because the model that AutoML solutions have provided to them is not performant enough. So the last option is custom models. This is obviously the most engaged way of coming up with your own model and ML services. You need to deal with the complexities of AI and machine learning, as well as productionization of such models yourself. In practice, we get the highest performance by using our own custom models, as long as we train them properly and the data set is available. But once you prepare your model, the infrastructure that you have is the only thing that you pay for. So what we've seen in practice as well is that AutoML has been used more than custom models and machine learning as a services, and this is usually because you don't need machine learning knowledge to do this. But again, custom models are the way to go to increase performance, and sometimes for cost reasons as well. Similarly, when we look at generative AI and foundation models, we have three different options. So one of them is prompt engineering via calling an API. You don't need to deal with the model directly. You just need to try to frame your problem properly, and you need to have some prompt engineering knowledge when you are dealing with foundational models through prompts. A second option is fine-tuning via API. So some of the providers of generative AI solutions provide APIs where you can use and you can pass your data to these models, and they fine-tune the model for you. As an example, OpenAI has provided APIs for people to fine-tune some of the GPT models. ChatGPT is not among them, but there are some others that are in that category. So you don't need to deal with lots of complexities in this scenario. But if you go and fine-tune your own model and you host your model, you can come up with better performance, but you need to deal with more complexity in this scenario. So we see the same pattern in traditional ML, and this is how you can see the world of options when you are dealing with foundation models and generative AI. So when it comes to different options that you can try, there are many different options across different providers, cloud providers, and the model providers. What is important here is that the strategies that these cloud providers have are different. So some of them host open source and partner models, and some others like Google comes up with their own models and provides services on top of that you can use. There are some considerations here when you want to choose different options. So performance is obviously one of the important ones, because you always have to make sure that you have enough performance for your own problem. And there are some problems that getting a wrong answer from the model might be very costly or catastrophic, and you have to be very careful about these scenarios. And of course, you can use human in the loop and other scenarios around the model, but you also want to work on the performance of your model a lot in these scenarios. And that's when we recommend using fine-tuning through hosting your own model. That's one of the examples. The amount of control and flexibility you want from your model is another reason that you might not want to use an API that is provided by you. Some of these models that are provided by APIs change as time goes by, and that is something to be aware of, that maybe in 3 months' time, you won't get exactly the same result that you are getting today if you are using these APIs. Privacy apparently is a concern here. If you are dealing with PII data or the data that you are not allowed to share because of regulations or other requirements, privacy requirements, you don't want to use the APIs. You probably want to use your own hosted model. Security is another concern here, because if you are calling an API provided by a different provider of generative AI, you might need to make sure that your servers and your backend has direct connection to those APIs, which is usually via internet, and there might be security concerns there. One thing to mention here, generally for traditional and generative AI problems, is bias. So if there is bias in the data, that bias will be reflected in the model, and that is something to be aware of, especially for applications that we are dealing with humans directly. Cost is another reason. As I mentioned, usually the APIs charge according to the number of calls as well as the number of tokens. But if you are hosting your own model, you need to invest in preparing that model, training that model. But once that model is ready, your cost would be your infrastructure rather than the cost of calling the APIs and the amount of data that is generated by these models. So there are many different considerations here, and there are many different options, as you can see on the screen, in cloud providers and in OpenAI. So with OpenAI, we can see that there is they don't allow you to fine-tune your own model in the environment that they provide, but there are many OpenAI models that are open source, and if you have the right machine learning knowledge, you might want to look at them if you need to host your own model on the cloud or on-prem. So let's look at some of the use cases and case studies. I start with predictive AI, and the reason being, firstly, we want to note that predictive AI problems will not go away. They will stay here, and they have their own applications. And also, many of the takeaways of these models and the way we go about solving these problems can be reflected in generative AI as well. Different organizations might be in different stages of their journey, of ML journey. So as an example, Sealy is an organization that manufactures heating and cooling solutions for residential and commercial properties. They are in the experimentation phase, and they've been experimenting with AI for better customer service by analyzing the cooling and heating systems, sensors, as an example, flame sensors, in order to find the degradation of these sensors by time and the sensitivity of them and how it is changing. Another example is Soup Arrow. So one thing I have to mention here is that for Sealy, as an example, it's a very specific problem. You don't expect these problems to be solved by a generative AI that has looked at unlabeled data straight away. And that's the pattern that we will see, that traditional AI will stay to solve specific narrow problems. Another example of predictive AI is Soup Arrow, which is in applying stage. And they are a drone logistic company that focuses on medical and essential supplies, but they have broadened their applications to other things like disaster management as well. And they have been using computer vision for safe landing of the drones. So as I mentioned, usually foundation models are very, very large, but when you are hosting a model on an edge device, which Soup Arrow is an example of that, you need to try to train a model that is very small and it doesn't require a lot of computational power. So they are using computer vision that are the models that are installed on the drone, and they process the images of the downward facing camera in order to make sure that the landing location is safe while the drone is landing. So these models detect humans by looking at the images and the videos and try to make sure that it is very safe for the drone to land. Another example of machine learning that is very specific, and you will need to have predictive AI to solve this problem. And the third example is Boltec. They are a large international insurance company, and they provide self-serve solution for phone screen protection as well. And they use machine learning and computer vision extensively. And one of the applications that they've been using computer vision for was to automate the insurance policies and claims for screen protection. They have models that are hosted on a phone of a person that is applying for an insurance, that will guide the person to take the right photos. And there will be models that are on the cloud, and these models are processing the images that are taken by the user in order to make sure that there is no crack on the screen of these phones. So as you can see, these are all examples of predictive AI. You need ML expertise and skills to solve these problems. So the barrier to entry is high, but these are very specific problems, and many of them cannot be solved by foundation models. Moving on, let's look at some examples of generative AI. Again, we see that companies are in different stages of their journey. An example of an organization that is experimenting with AI is one of our clients that is an education startup, and they are integrating generative AI through calling APIs in order to support teachers in providing timely feedback on students' writings. And the second example is Power Sensor, which is one of our startups. It's an IoT startup that provides real-time energy usage, and the device itself can be used for solar energy generation analysis. And through these devices, we are collecting lots and lots of IoT data. And our team at Power Sensor is experimenting with generative AI to help non-technical people to interrogate and query IoT data. So this allows a user to write in plain English or natural language what they expect to get from these models. And basically, the plain text is converted to a set of queries, and these queries are sent to the analytics platform that is keeping the data inside. And the query is run, and the insight or the result of the query is returned to the person. And this is how a non-technical person can interact with the IoT data. Another example is what you see on the screen, and this is we want to talk about this because we've seen that many of our clients ask us whether generative AI is a good solution to create chatbots and conversational AIs. The answer is definitely yes. Traditionally, chatbots were made by a very manual process where a person would sit down and just map out the flow of the conversation into a graph, and they would use intents or the words that might appear in the conversation. And it was very narrow. It would do specific things. And if you had ever interacted with such chatbots, you realize that these are very dumb and they are not very smart in the way they behave. But with the generative AI models, we have a different approach to solving the conversational AI problems these days. And in this example, Finder GPT is using generative AIs to make asking questions about your knowledge base possible. So you can, let's say, import or introduce your PDF, or let's say you connect this to your website, and a chatbot will be provided for you so that you can go and ask questions about your knowledge base, and the chatbot would go back to you. So this is another example of an organization or a use case that is experimenting with generative AI. And generative AI is used in this specific application for providing the search, and also a chatbot on top of that you can interact with. And lastly, the last example we'd like to talk about is DataArc. So this is an example that the new techniques can solve problems that couldn't be solved before. And this specific example is we are using generative AI in this example to help the predictive models and computer vision models that are being used in a pipeline. So DataArc is another startup by DiUS, and they provide a machine learning powered platform that can help geologists with decision making throughout the exploration and mining process. So the way we've used generative AI in this specific example is that there were some of the rocks, the images of the rocks that would confuse the models because there are vertical lines as natural textures on these. And the task was to find the cracks in these rocks. And we came up with a generative AI model that enhances this image and smoothens out all the patterns and textures on those rocks in such a way that we still keep the the cracks. And once this process is done, the modified image is sent through the pipeline, and you can see that this will improve the performance of a crack detection model that would go and detect all these cracks in these models. So this is also another example of generative AI, which is applied in practice, and image variation and enhancement is one of the generative AI applications that you can see here. So what are the takeaways from the talk? So we know that generative AI has made it possible to address some machine learning problems where data has been the biggest barrier before. But predictive AI and generative AI have their own applications, and they're here to stay. We don't expect to see that the traditional ways and approaches to solve machine learning problems will disappear. We know some specific problems that generative AI has lowered the barrier, and it would be a good way to tackle them. But there are many, many more that you need predictive AI for as well. Another takeaway is to make sure that you know the risks and considerations when choosing among different options, performance requirements, the control and flexibility that you need from your model, the cost of running your services, the bias in the data is another important problem, security and privacy and PII data, and changes in the underlying models might be something to have in mind. And lastly, our technical team has skills and expertise across both predictive and generative AI techniques and models. Please come and talk to us if you have a problem. And with that, we do have a complimentary to our machine learning workshop where one of our machine learning consultants would sit with you, look at your business problem, and review and recommend strategies to address that problem using machine learning. This can be generative AI problems or predictive AI problems across many, many different applications that are available. So with that, I think I close. And if there are any questions, please post them on the Slido, and we will be happy to answer.
Thanks, Shaheen. We do have a couple of questions. We're right at time, but maybe we might just answer one or two. I think the first one that we're going to answer is for you, Shaheen, which is given data dependency for machine learning, are there any insights on what could be the underlying data-related issue? So regulatory, data availability, complexity, quality?
Right. So that's right. So when it comes to generative AI, these models have looked at a lot of data, and there are even fines and lawsuits against different companies that have created these. But once the APIs are provided for you, you can make use of them whenever it's a problem that is generic enough that these models do well for you. But again, for many specific applications, I think you want to go down the path of hosting your own model, whether it is predictive or generative. Again, for the same reasons, because you might have requirements for your privacy or other requirements and compliance that you need to apply.
Okay, great. I know we're at time, so if you have to go, obviously, thank you for attending. We're just going to answer a couple more, and we'll make a commitment to follow up, I think in the follow-up email, Erin, with everybody who attended. You'll get the recording, and then also to any questions. So if you have to go, thank you for attending. We really appreciate it, but we'll just take like 2 or 3 minutes to answer a couple of questions. Yeah, so there's another one for you, Shaheen. How do you think we'll manage AI hallucinations?
Oh, that's a
big question.
Good problem, right? A very good question, right? So Look, as there are advancements in generative AI, that's one of the problems that the providers of these services are trying to deal with. There is no right or wrong or direct answer to this question, but we are seeing that the models are putting, or the providers are putting basically services around these models to try to find when the model is hallucinating and just probably provide an answer that we can't give you the right answer. So that is because the structure of these models are in such a way that they would make up some answers if they don't know the actual answer. So and the amount of power of analysis in these models is probably pretty low. So the way I look at it mostly is that they are very good at going and fetching the information that they've seen before, but with things they haven't seen before, they try to find similar things, but in practice, they might not be correct. And they are very assertive at this point in time. So that's something to be aware of all the time. And that might be the reason that you want human in the loops in these specific scenarios where that is very important as well.
Okay, last question, Shaheen, again for you. There were a few for me, and I will get to those. But what are the risks of using AI APIs for a chatbot? Is it possible to train them not to generate unrelated, unwanted, or incorrect material?
I think this is the same as the hallucination. Unfortunately, this is a problem at this point in time with generative AIs. Again, you probably want to make sure that you have a bit of checks on top of what you get from these models. And again, I think you have to try to tweak the problem and use generative AI for specific problems where a bit of incorrect answer might be tolerable or acceptable. So it will change for sure with passing more data, with larger models that have more power of analyzing your data. But at this point in time, there's no good solution. Though there are ways that you can prompt engineer your problem and probably give them a chain of thought to the model that it would follow in these scenarios. And that would solve some of the problems. But again, there is no guarantee that you will always get very good answers.
Okay, I think we'll stop. We do have other questions, but I think we'll work to address those and commit to getting the answers out to everybody who attended or everyone that registered. Look, thank you, everybody, for attending. It was lovely to have your company. We really appreciate it. And yes, we hope you have a lovely rest of the day. Farewell.
Thank you, everyone.